output metrics for the new line are exceeding projections.
I agree. The neural network optimization made all the difference. Can we see the lens assembly tolerance on the Z-axis?
Yes, rotating the schematic now, the clearance is optimal.
The voltage spikes correlate exactly with the screen flicker.
Here. Let's try isolating the power source to the display driver.
The precision laser cuts through the reinforced glass, reaching temperatures that turn the material instantly into plasma, creating a flawless edge. In this massive distribution hub, advanced robotics ensure the seamless flow of materials, from raw aluminum to finished glass panels. This fine mist creates a durable, ultra-smooth protective layer, ensuring flawless display quality.
In the darkroom, the displays undergo rigorous testing, cycling through white, red, green, and blue to ensure perfect brightness uniformity. To ensure reliability, the batteries are subjected to temperatures as low as -40 degrees Celsius.
The white balance on the new sensor shows a slight blue shift here.
We need to recalibrate the lighting environment and rerun the color checker.
This slow-motion shot highlights the precision bonding process, where the heated press secures the display, creating a seamless, waterproof seal.
The steady state analysis looks good, but the sweep shows that spike.
All right, I've logged the data point